Today we're going to talk about Fermi questions. Fermi questions basically deal with the concept, how large is the crowd? That's an example of a Fermi question. It requires estimating physical quantities to produce an answer. Enrico Fermi was an Italian physicist known for his ability to take limited information and arrive at a reasonable numerical estimate. He approached a problem by setting a lower estimate, a value the item in question was more than, and an upper estimate, the value the item in question was smaller than. Fermi then worked through the problem using his approach and reached a numerical estimate within identified limits. Fermi worked at the University of Chicago, and his classic question was, how many piano tuners are there in the city of Chicago? Fermi questions rely on making logical assumptions about a situation to reach an estimate to an order of magnitude, usually a power of 10. That is, the estimate is expressed in hundreds, thousands, millions, and so on, whatever unit is appropriate for the question. So another example of a Fermi question is, can every person fit inside a cubic mile? What assumptions do you need to make? What information do you need to find? The way I approach these types of questions is I have questions of my own that I ask so I can get information for the assumptions that I'm going to make. What is the average size of a person? What does a cubic mile look like? How close together will everyone be? Will they be standing, sitting, laying down, etc.? So here we have some assumptions. First assumption I will make, assume that everyone can be described with an average height or weight. Second, I will assume the cubic mile land is flat with no obstructions, no hills, no buildings, just flat land. And third, we'll assume that there is no space or extremely little space between anyone. There might be more assumptions you could make, but these are the ones that you might create when trying to answer this Fermi question. Here's a list of some Fermi questions that you guys are going to be doing whenever y'all do your project for Fermi questions. These questions we will divide out randomly and assign to different groups. You will then present all of the information that you arrive at, the steps to find your answer and the answer, all the assumptions and everything involved in finding your Fermi question answer. So we went ahead and created a Fermi question. How much would a stack of $1 bills total that could fill the newest Rowlett water tower? So come the questions that we'll have to ask. What is the volume of the water tower? What is the volume of a $1 bill? And will we fill the tank only or the pipe that the water comes in and out of? So our assumptions, and we make these assumptions without research. We can see the nearest water tower, we can make some estimates. They may be off, but we're just making some estimates. We also have seen a $1 bill before, so again, we can make some estimates based on just our previous knowledge. So we're only going to fill the tank. We know that the tower is basically cylindrical. The radius of the tower is approximately 30 feet. The height of the tower is approximately 50 feet. A $1 bill is about 2.5 inches wide, 4.5 inches long, and 0.5 millimeter thick. So we're also going to need some conversions. So we're talking about volume, so we're talking about units cubed. So here, if we take a 1 foot cube and we convert it to inches, we're looking at 1,728 inches cubed is the same as a foot cubed. Also, because we used millimeters, we know that 1 millimeter is approximately 0.04 inches. You will need these conversions later, and they will come up through our mathematics. So first we need to find the volume of the tank and the volume of the $1 bill. We're going to start with the volume of the tank, and we have volume of a cylinder is pi times the radius squared times the height. So that is pi times 30 feet squared times 50 feet, which is approximately 141,300 feet cubed. Because the dollar bill is in inches, we have to convert this to inches cubed. So that is going to be multiplied by 1,728 inches. And you'll get 244,166,400 inches cubed. Now we find the volume of a $1 bill. We take the length, 4.5, times 2.5, the width, times 0.02, the height or the thickness. Remember that 1 millimeter is approximately 0.04 inches, and 0.02 is half of 1 millimeter. So when we multiply these, we get 0.225 inches cubed. Now we want to see how many of these dollar bills will fit into the tank. So we take the volume of the tank divided by the volume of the $1 bill. 244,166,400 divided by 0.225 gives us approximately $1,085,184,000. Ladies and gentlemen, that's an example of a Fermi question.